Dear all, welcome to this new episode of Ecotia TV, today on sustainable infrastructures. What we are going to talk about today is a very global topic. It is about space. And space is a major concern today with the explosive population growth, and smart use of space can ease the congestion and pave the way for sustainable urban development. Civil engineering deals with the design, construction, and maintenance of a multitude of built environments such as public works, roads, bridges, canals, dams, airport, pipelines, structural component of buildings, and railways. The demand for smart materials, intelligent electrical grids, and smart buildings with embedded sensors is giving civil engineers the push to innovate in sustainable designs that are forward-looking. Additionally, increasingly complex construction projects require that all teams rely on common languages to facilitate collaboration and reduce rework between phases. One of the key areas of focus could, for example, be zero-energy buildings, by insulating structures with double-skin facades or integrating panels that facilitate better usage of the captured energy. To talk today about this very strategic trend, I will pass the screen to Jonathan Asher, who is our CATIA Architecture and Construction Portfolio Director here in DS. And Jonathan is going to present you how CATIA envisions this trend, the answer to its challenges, and how large civil engineering companies in China or in North America uses CATIA to innovate. Thank you, and welcome, Jonathan.
Thank you very much for the introduction, Cyril. My name is Jonathan Asher. I am the CATIA Construction Portfolio Director for the architecture, engineering, and construction related solutions that are released on the 3D Experience platform. I'm happy to be here today to discuss with you some of the emerging or some of the overlying trends in the construction industry. One of them, first and foremost, being sustainability and the ecological footprint that the construction industry has in the environment. It's common knowledge within the industry that construction is one of the largest carbon emitters within a given country. And the larger the country, the larger the carbon issue. And what we see is there are two main outputs of pollution against the environment. The first is, of course, the carbon footprint, carbon emissions that are associated to every step, every process along the supply chain, from the design, engineering, manufacturing, transportation, installation, and eventual occupation of an infrastructure project, whether that's a large road or a rail station or a new rail line or a transportation hub like an airport or a bus terminal. So we see that the supply chain of the raw materials to finished products to installation takes a large portion of that carbon footprint. And the second aspect is landfill waste and the amount of material that goes as an output from that supply chain through the entire process to the job site and eventually ends up in the landfill. Whether that's excess material that's cut off and thrown away during the installation construction phase, or that's material that's been produced incorrectly, that's been shipped all the way to the site, only for the installer to realize that this is either the wrong size, the wrong dimension, the wrong material, the wrong color, and that gets set aside, and if it can't be reused, it also goes into the landfill. So construction waste is a massive issue within the industry, and that leads me to what we're doing from the CATIA perspective to support sustainable design. Is that we are providing engineers, we're providing designers with the tools required to get things right the first time, to eliminate all of the unknowns from a project so that when a material goes through the supply chain, arrives on site, it has been fully vetted on the 3D Experience platform. It has been qualified, and when it arrives on site, it can be installed directly with no manipulation, modification, or otherwise. So that we're reducing waste by allowing designers to foresee issues, to identify issues, to alleviate those issues, and then to go ahead and install. And how do we do that? Well, by allowing designers to model to extreme levels of detail, by modeling to the full 3D experience twin of a project. I won't say that it's in the digital twin, the 3D experience twin. We say the 3D experience twin because the reality is there's no other software in the world that will allow designers, engineers, and fabricators to model to a level of development of 500. To model the as-built. And so as a project develops over time, the designer is able and the engineer is able to model their project to the highest level of detail. And what that does is it removes uncertainty from the project. So when you remove uncertainty, you know that the product that you're delivering, when it gets to the site, it is buildable. It is what it needs to be. And by eliminating issues in the supply chain, by eliminating errors on site, and by eliminating construction waste, we are in effect pushing a more sustainable construction process. And we've seen successes across the world by our customers who are using 3D Experience and CATIA to model their projects from early design phase through manufacturing and then the construction. And their biggest drive in all of this is to get things right the first time. Because when you are modeling correctly with real geometry and you're managing your supply chain with a 3D modeling centric approach, you're able to realize gains and maximize efficiencies.
Thank you, Jonathan. We can see now that infrastructures is really one of the most impacting industrial products in the world. It is impacting during its construction phase as well as during its usage. In permanent search for efficiency while respecting the environment, discover how CATIA positions itself toward helping civil engineers implement their visions and maintain existing infrastructures, all in the most collaborative way.
So I'm very excited to show you the portfolio for civil infrastructure and the portfolio that's going to support a sustainable design for civil infrastructure projects. Again, a reminder, the motto for CATIA is to shape the world we live in, and this is perfect for the construction industries. In 2020, we're focusing our industry on these three different segments from a CATIA perspective. And so we're looking at overall addressing the transportation infrastructure segment, building and facilities segment, and construction products and services segments. Our solution portfolio is structured in a way that addresses each one of those individual segments. For sustainable infrastructure, we're looking primarily at the upper left with the civil infrastructure engineering solution. A zoom on the civil infrastructure engineering solution, and we see that there are four primary processes that make up this solution. There's the civil infrastructure design process, the civil structures engineering process, the civil systems engineering process, and the civil construction process engineering process. Each of these processes have a brand attached, and those brands are the primary supporting brands that contribute to the value of these processes. Each of these processes then comes with a packaged set of roles, and in 21X, we have completely re-engineered our role portfolio to be industry specific. This was already the case from CATIA back in 2020, X, and previous releases. But for 21X, we've taken it one step further and greatly enhanced the portfolio. So in re-engineering our role portfolio for 21X, we've taken the principle of continuous level of development as a guiding force. And what that means is we've embedded template creation and template instantiation capabilities in a number of roles to allow companies and individuals to leverage knowledge and know-how, embed intellectual property into their templates, and then allow them to instantiate them through either out-of-the-box technology such as component-based design, or to write custom scripts and algorithms to do that automation and instantiation based on specific rule sets that are particular to a given project. So here we see the 21X portfolio in detail. We have roles that are focused primarily on design and roles focused primarily on engineering. And then they're split. There are a few of them that are specific to buildings, a few that are specific to infrastructure, and a grouping of roles that are applicable to either a building or infrastructure projects, particularly for systems coordination or presentation and review. On the infrastructure side, we see that we have the computational designer for construction coming out in FD01. We have the civil designer role that's focused mostly on design, and then we have the civil engineering role that can do design or engineering and the template capture and reuse. This is why you see the roles on the right have been highlighted in red. Within those roles, we have the template designer inside. The old 20X template designer role has been included specifically within these roles to allow for that template capture and reuse capabilities. Also in 21X, we've released a new navigational system that is accessible through the compass that will allow you to start from a solution experience, navigate to the individual process experiences that make up that solution, and then drill down into the individual roles that are packaged within that process, roles that contribute to the success and the overall execution of that process. Here we're focusing specifically on the civil infrastructure engineering solution. We see that one process within that solution is the civil infrastructure design process, and then there are 6 roles packaged within that process. The computational designer for construction, building and civil presenter, the building and civil model coordinator, civil designer, civil engineer, and templates optimization and rules designer. This is just one path through the Maya 3D experience. A closer look then at each one of the processes within that solution. We have the civil infrastructure design, structures engineering, systems engineering, and process engineering, and the roles packaging associated with each one of them. We're going to look now a little closer at the civil infrastructure design process and how the roles within that process contribute to an overall workflow that's going to go from ideation to manufacturing for a infrastructure project. First, a quick look at 2 roles that I'd like to identify individually. The civil designer role. The civil designer role contains a number of applications that allow users to do linear infrastructure design, such as alignments, road surface design, rail surface design, that includes super elevation, along with earthworks, excavations, filling, and terrain modeling. This is a very robust role to do design and engineering of an infrastructure project. The second role that I'm going to highlight is the civil engineer. You see the civil engineer is nearly identical to that previous role. It allows for the design and engineering of an infrastructure project, but we've included additional capabilities that include the template creation and script writing for automation using traditional CATIA knowledgeware like rules, knowledge patterns, actions, reactions, and the capturing of these automation templates. Looking at this process more holistically, we see that there are sub-processes that make up that process. Traditionally for an infrastructure, a linear infrastructure project, the first sub-process is going to be the creation of an alignment. This alignment is going to be situated within the context of a terrain or a larger site within a territory. And then in parallel to the creation of that alignment, there's going to be the design and creation of detailed content or componentry that goes along with that. Because with any infrastructure project, regardless of scale or complexity, we try to reuse as much as possible similar components. And beyond that, every component is patterned in some way, shape, or form. So there's a parallel subprocess that goes along with the patterning of those components. Finally, on the right, we capture those components as parametric templates so that we can instantiate them and we can replicate them in an automated way using the component pattern specification and the alignment, the context, the overall skeleton design of the model. We run an assembly instantiation, so we're instantiating then automatically those components. And finally, we're producing design documentation, whether that's a 2D documentation or 3D documentation, or the experiential documentation that is virtual reality or augmented reality or other types of immersive interactive documentation. The portfolio to support that then is The civil designer is going to be used primarily for the context design. The civil designer, along with the computational designer, is going to be used for the component patterning specification. And then the civil engineer is going to be used to capture the templates, instantiate those templates, and then produce design documentation, along with the building and civil presenter. If we take a cross-section of any project at any given time, we see that there's the distribution of roles that are going to be deployed on that project are going to change from phase to phase and relative to project complexity. So as we move through concept design, through schematic design to design development, you see that the cross-section, if you take a vertical cut through one of these phases at any given LOD, the usage of roles, the distribution of roles at that phase will be slightly different, where we're going to go progressively from the civil designer to the civil engineer as the need for more detail, the need for more development evolves with that project. Now, a couple of videos to show specifically what each of these roles are capable of. So with the civil designer on a linear infrastructure project, we're going to first start with a context. We're going to bring a point cloud in. We're going to mesh it as a terrain. We can project then the image onto that terrain and start modeling the alignment. First, we'll start with the horizontal alignment to set that out and plan. And then we'll start with the vertical alignment and work in the vertical elevation of that alignment. We'll add transition curves and station points and define at each one of these station locations what's happening. So is this the beginning of a tunnel, the end of a tunnel? Is this the beginning of a bridge? Is this the end of a bridge? And then we can interactively change where those are along the alignment. We can also assign attributes to each one of those stations. And for example, we know the beginning of the tunnel, the end of the tunnel, we know the terrain that we're working through. And so we can compute excavations directly through this alignment command. When we exit the alignment, we start to create the horizontal surface, and we have what's called the bridge assistant that's going to allow users to interactively create and design specific bridge segments with the different components that make up that bridge. Users are also able to create their own parametric content that can be used for something like a tunnel. Here we have a tunnel with a number of different lanes as parameters. These tunnel components include not only the lanes and the dividers, but also rebar and all of the ring segments required for this tunnel construction. And once the design is done, we will navigate the experience with a fly-through to be sure that the design conforms to all requirements that were outset from the beginning. Next, an example of a parametric bridge design using the computational designer for construction role. One of the primary applications in this role is XGenerative Design, the algorithmic generative design application that runs completely on the web. In this example, our engineer has designed a parametric and generative bridge with a number of driving parameters that define the design. That model has been defined as a template, and that template can then be instantiated into a model, and the parameters can be manipulated to perform different design variations. Once a design variation has been selected as the design to pursue further in detail, we can connect that design to detailed engineering templates using component-based design to automatically instantiate those components. In this case, this component includes rebar. And because it's entirely linked through a parametric chain of relationships, when you update the original design, then those updates will be directed and trickle down into the detailed components. So when we change the design of the bridge, the rebar is going to update parametrically. So that late stage changes of a project can be absorbed further and further downstream without any massive rework or redesign. Finally, with the civil engineering role, once our design has been created and we've explored design variation and we're ready to start building with detailed componentry for manufacturing, we can use a civil engineering role to capture these templates for manufacturing and instantiate them automatically using component-based design again into our contextual model. So in this case, with this suspension bridge, the cabling stays have been modeled to a high level of detail, and we're going to instantiate them automatically using the light skeleton model as a contextual reference. And we will do that then for all components, all elements of this model, including the decking. So there you see an overview of our CATIA solutions for civil infrastructure, design, and engineering. And we're more than convinced that with these set of solutions, we're able to perform and execute and deliver on our promise to shape the world we live in.
Now, with our customer roundup session, we will discover innovative customers in the field of infrastructures engineering. They all have in common to use CATIA and the 3D Experience platform to push further their own capacities to provide sustainable innovations in their fields.
BIM technology enables project excellence of Beijing-Xiong'an Railway. 1. Project overview. Beijing-Xiong'an Railway connects Beijing and Xiong'an New District. The main line is 92.8 kilometers, including 5 new stations: Huangchun, Beijing New Airport, Guan East, North Bazhou, and Xiong'an. Control and key spots: Airport Number 2 Tunnel, Xiong'an Station, and over 20 major overpass projects. 2. BIM design. Throughout the life cycle of design, construction, and operation, 3D Experience is adopted for multidisciplines, including bridges, tunnels, subgrade, station yards, station, tracks, electrical, communications, signals, traction transformers, catenary, piping, and vehicle place. Creating railway design collaboration platform on 3D Experience, incorporated with China Railway BIM standards. The design software is developed with parametric technology to achieve high efficiency in designs. All disciplines carry out real-time collaborative design based on a single data environment. A unified framework is adopted to realize the standardized exchange of cross-disciplinary information. The BIM model is managed by the engineering structure tree, and the entire design process is integrated. Management and design data sharing a single data source. Tasks and schedules, review, etc., all managed in the platform. Using collaborative 3D Experience to optimize the curve layout of multi-line bridges and the relationship between multi-line and the bridge structure. Improve the system structure and constructability of designs. Through multidisciplinary collaborative design, ensuring the smooth connection of the airport tunnel exit. For the first time in China, we achieved one-to-one high-precision 3D modeling for the entire railway line. Using 3D Experience, the detailed 3D design of number 0 block of long-span continuous beam is done. Optimize pre-stressed tendon and structural rebars. With strong motivation from China Railway, 3D Experience technology is developing in railway industry rapidly and play an important role in planning, design, construction, operation, maintenance, reconstruction throughout the entire life cycle of projects.
Thank you again, Jonathan, for having presented the parts of this CATIA TV episodes. Now, if you're okay, we can discuss a little bit about the future of the field of infrastructures. So my first question would be, where do you think the world is innovating the most in terms of sustainability? What country could be the most innovative? The second question would be, what kind of factors could be the triggering of innovation in infrastructures? Would it be constraints? Political will? And the third question would be, what are the main blockers in making infrastructures sustainable? Thank you, and I wish you all a very good day in these very particular situations that we're living.
Those are great questions, Cyril. First, where are we seeing most innovation happening? Well, I think there are a couple different places that we're seeing it happen. First is where governments are mandating new and progressive techniques to be deployed in construction. We see that happening in certain parts of Europe where there's a requirement, a government mandate, that we need to be more focused on the environment to produce more environmentally friendly buildings. We also see this happening in places that are just emerging in new markets. So there's the old world progress and push, governmental push, and then there's the new world developing markets that are pushing new and innovative construction techniques because they don't have a legacy that is pushing them in one way or the other. And so for them, they don't have the constraints of established supply chains or supply networks. They don't have the constraints of traditionally deployed building materials that have been pre-engineered or pre-calculated, and there's no hesitation there economically or from a personal standpoint from the designers to push forward with new and innovative materials. So those are two places where we see innovation happening either through government mandates or through personal motivation in emerging markets. Another place where we're going to be seeing more innovation coming in the future, in the near future, is of course a product of the coronavirus and the need to rebuild economies and to rebuild lives, really. There's a lot of countries around the world that have been lagging and letting their infrastructure kind of lag behind as they developed other portions of the economy. And just like we saw coming out of the Great Depression and the World War II in Europe and in the United States, there's going to be a push towards the reconstruction of infrastructure and the modernization of infrastructure in the coming years, especially following the current economic situation. So infrastructure and the reconstruction and the modernization of infrastructure is going to play a large role in the coming years. And if that is not made sustainably, if business processes are not radically transformed to create, to design, engineer, and then build these new infrastructure projects, we're going to find ourselves in a very difficult situation in the near future. So I firmly believe that with these new government initiatives to develop infrastructure, a large portion of that is going to have to go towards the research, development, and then deployment of sustainable technologies, and something that will last another 100 years and beyond. Because if we want to eliminate the landfills and we want to eliminate all the materials that would go from a construction site to the landfill, we need to make major progress on durability and the longevity of our infrastructure. And from my perspective, the main blocker in making an infrastructure, a piece of infrastructure, sustainable is going to be scale. because these projects are so big and they cover so many different value streams, and so many different people are coming into a project, leaving a project, the project is changing hands so many times. How can we maintain a single goal and a single focus of sustainability as we execute, as we design, engineer, manufacture, and then eventually assemble and occupy these large infrastructure projects? That's going to be the big challenge, but the fact that this is a global trend means that we will see real progress in the near future. So thank you very much for attending the webinar. I hope you learned a lot about sustainability and our civil infrastructure solutions on the 3DEXPERIENCE platform. We've got a lot of very exciting things coming in the 21X, and even more to come in the future. So have a great morning, afternoon, or evening, wherever you are. Bye.